Welcome to the February 2025 News Roundup of the Climate Reflections podcast. Each month, we release a roundup of news related to sunlight reflection methods, or SRM, from the month before. I'm your host, Dr. Pete Irvine, and today I am joined by several leading SRM experts. Would you each mind introducing yourself?
Yes, my name is Michael Diamond. I'm an assistant professor at Florida State University, where I study clouds and climate change.
So I'm Rob Bellamy. I'm a senior lecturer in climate change and society, interested in how society perceives new technologies like geoengineering.
And my name is Viktor Jaakkola. I'm the head of scientific collaboration in NGO Operaatio Arktis, calling in from Hansen.
Great. Well, thanks all for joining. So first off, at the end of January, the Arctic Ice Project, which was formerly known as ICE 911, announced they were shutting down. The project started more than 10 years ago with the goal of protecting and restoring sea ice in the Arctic using hollow glass microspheres, which would float on the surface and increase the amount of light reflected. However, recent studies suggested that those materials might pose a risk to the Arctic food chain. And so the researchers, finding no solution, finding this threat credible, decided to shut down the project. Viktor, turning to you first. Your organization, Operaatio Arktis, has been following these Arctic interventions closely. And you wrote a brief comment for our website on this development. What was your reaction?
Well, ICE 911 research was the first SRM idea that I stumbled on. So in that sense, their work has had quite a remarkable impact on my way of thinking. I've actually never spoken with Dr. Leslie Field, but I've watched some interviews and so on. What I can say about this news is that although it's nice to have a lot of different ideas out there, that kind of gives a sense of there are a lot of different options. It can also help to narrow down our focus a little bit on just a couple of ideas that seem like they have the most potential.
And it seems like quite a good reason to shut this down. I think there was also another paper that came out a couple of years ago that suggested that these glass microspheres might actually produce a warming effect and actually be counterproductive under certain circumstances. But there wasn't just sort of a scientific, technical issues potentially with this idea. There was quite a lot of controversy around it. Do any of you have a sense of how that went down?
I know that there has been quite vocal resistance towards this very idea in Alaska, for example, among indigenous communities and others who may not have been consulted as transparently as they should have, and felt like they weren't really a part of this evaluation process.
I can't speak to what the researchers were thinking when they decided to pull the plug on this project, but when I first heard of it, actually, I thought it was somewhat of an optimistic story, or at least had a silver lining to that cloud of it not working. It's really important that these groups are able to take no for an answer. That's the hallmark of responsible research, right? We're trying to come up with falsifiable hypotheses, and to a certain extent, they actually met the gold standard of succeeding in science. They were able to falsify their hypothesis that they'd be able to do this safely, and not seeing a way around it, they decided to shut it down versus continuing on.
Well, that segues quite nicely to our next piece, which is about the trust that the public should have or not have, and where those sources of trust come from in terms of these topics. So a new study came out this month that draws on focus groups and a survey across 22 countries, asking the public who they trust when it comes to information about carbon dioxide removal and SRM. Rob, you've done quite a lot of this kind of work. What did you make of this new study?
Actually, first, I was just going to riff off something Michael just said. I completely agree with that. I think this Arctic case study is a brilliant example of responsible innovation in action. This kind of ability of scientists to self-govern and recognize when to actually stop, I think, it's a win for the kind of self-governance argument in that respect. Anyway, so that aside, this other study, there's a lot of trust shown in scientists from this survey. Do I find that surprising? Not really. So scientists often kind of top, or at least come near the top in kind of surveys of the public when it comes to kind of trying to find out who people trust. So in that sense, it's not that surprising. The thing is that once you kind of drill down beyond that kind of high level binary of trust or not trust, you actually find that people are trust selective. So people tend to trust scientists that say things that resonate with their kind of worldviews, and they don't trust those that don't. So I think it's it's another data point in the kind of do people trust scientists arena. I think the next steps are to try and understand which scientists do people trust and why. Which kind of perspectives are kind of getting on board with which ones and which ones aren't.
You're sort of highlighting the importance of the scientific answers. Kind of those, whether they're favorable or not, determines partly how people trust them. So, to what extent can researchers or the institutions that support them do anything that helps beyond just produce results the public wants to hear?
Well, I mean, this is the kind of the problem that we're always unfortunately going to be faced with, is because nothing you say will appeal to everybody. There's always a kind of minimum level of divergence in society's perspectives on any one thing, and as we know, geoengineering is one of those things that tends to be more divisive than most. So the kind of trick when it comes to trying to communicate these things and ultimately trying to govern them is to try to attend to these divergent worldviews and to try and get everybody to do the same things, or at least kind of permit the same things, but for different reasons. And you always need to recognize the fact that people are coming at it from a very different angle.
So one thing this study also noted that the authors seemed quite disappointed by was that social scientists were not very frequently mentioned as a trusted source of information on these topics.
Was I surprised by this? Again, not really. There's a kind of popular separation in society at large, and formally within academia, between the natural sciences and the social sciences. Between technology on the one hand and social stuff on the other hand. So the kind of basic perception goes, okay, well, social scientists are not working on the technicalities of how does this particle behave in the stratosphere, so they're not experts. And that's very much the case in relation to that particular area of expertise as it pertains to geoengineering. But something I always like reminding people of in any of these kind of technological controversies is that geoengineering and any other technology, they're not just bits of equipment. They're socio-technical systems, coupled combinations of technical artifacts and social arrangements. And the reality is that the technology, the bits of kit, simply won't work without those social bits. It won't work without people. It won't work without policies. It won't work without procedures. It won't work without any of that stuff. So it won't work without social science. So this is why we need an interdisciplinary endeavor. But yes, I mean, the recognition of this fact is quite lacking, I think, in academia and society.
Well, I guess the social scientists will have to struggle on doing good work, underappreciated.
Yeah, what comes to mind is like the non-use agreement on SRM. I believe quite a lot of the signatories referring to that open letter are from a social science background, which might indicate a little bit of this divide where natural scientists are maybe disregarding some social and ethical aspects a little bit, whilst then social scientists may not be looking at the physics as closely and realize the need for SRM, but more focus on the social hurdles and ethical dilemmas.
And it might be worth noting that the non-use agreement often characterizes their signatories as scientists, perhaps because of the perceived trust in them.
Yeah, exactly. That's an interesting point, that. And yeah, I don't know. I mean, you'd need to kind of look into this a bit more, but my sense is that social sciences as well tend to be, particularly if you broaden the net wide enough to include humanities scholars as well, tend to be a bit more comfortable with normative perspectives on things. So I think they're a bit more comfortable about kind of saying, no, we shouldn't do this, and adopting a particular perspective on things, which is fine. We very much need these voices as part of the conversation. The key is to remember that, it's not the only kind of perspective on an issue.
So, on another subject, a new review has come out of the World Climate Research Programme's Lighthouse activity on SRM. A new paper by Jim Haywood identifies research gaps across the field. Now, This team specifically focused on research gaps for the leading SRM proposals, stratospheric aerosol injection, so SAI, and marine cloud brightening, MCB, and particularly they focused on the technical and scientific questions. So Michael, what did you make of this review?
Yeah, so I think I'm going to sound a little bit like Rob here in saying that I wasn't particularly surprised by most of the findings. There seems to be a consensus right now in thinking about the technical feasibility of these proposals, that we have these kind of categories. Can you actually make the particles that you want and deliver them? Once they get there, what are they doing? Can you do it at the scale that you would need for a given cooling that you might want? And then what would the effects be on the atmospheric circulation and therefore impacts for people and ecosystems? So we're kind of all drilled in on what are the big topical areas. Where I was a little bit surprised is where they said some of the answers or new work might lie. In particular, compared to, I think, previous assessments, they seem particularly bullish on the idea of mixing methods. So thinking about maybe not just doing stratospheric aerosol injection or marine cloud brightening, but what if you did both? And we have, one or two studies doing that. But they're saying that we might need much more of that and much more consideration of not just what are these solar reflection or sunlight reflection methods doing, but how are they also interfacing with mitigation? So things like changing the amount of sunlight available for renewable energy production or for carbon dioxide removal, decreasing temperatures but keeping CO2 levels high for at least a certain period of time might actually help us a little bit on the carbon dioxide removal front. Maybe. I don't think we have the answers yet to be able to say that.
And so do they also, so this is the paper's title focuses on research gaps. Do they also speak to the means by which you fill gaps? Like, is it mainly modeling? What kind of needs to be done to address these scientific gaps?
Yeah, I think the big maybe takeaway that not everyone is willing to say is that they do talk about outdoor experimentation. In particular for marine cloud brightening, they do have the lack of outdoor tests of particle dispersion as one of the main key gaps for marine cloud brightening in a way that is a little bit different for stratospheric aerosol injection. Stratospheric aerosol injection, they are more recommending high-resolution modeling studies before actually going out into the real environment. We've had some really nice model comparisons between these global circulation models. Not a lot of them have participated compared to those that have participated in some of the big marquee global warming experiments. But the bigger gap that they address is that some of the models with cutting edge capabilities in representing the stratosphere or representing ice nucleating particles for cirrus cloud thinning, there's sometimes only one or two of these models actually that we have. And when you compare those against each other, they often come up with very different answers. And that's just a model comparison of two. So one of the big things is not just comparing any model you can get your hand on, but making sure that we're comparing the state-of-the-art models or potentially developing these state-of-the-art schemes independently in separate models so we can compare across them.
From a social science perspective, we're lacking knowledge on governance at the moment. So, we were talking before about a big survey that's come out on how people perceive these technologies and things. And there's quite a lot now about how people perceive the technologies, but not so much about how we should handle them. We've had lots of governance principles as well that are being drawn up by various experts, natural science experts and social science experts. Loads of governance principles now, but there's been very little public input into actually what governance principles should look like, and indeed what governance architectures should look like. And this is actually something I'll do a little plug now for our project, Co-Create, that's looking at this very question.
I can't wait to find out more about the results of that project. Well, you've teed nicely up the next piece here. So there's a new study or another review by Rose Foster and colleagues focusing on the governance of marine cloud brightening at smaller scales, drawing on existing literature, and they make 13 recommendations. I mean, one of the things I took away from this, as well as a recent piece by Karen Brent and colleagues, is that the academic community, at least, seems to be converging on what the high-level principles ought to be that would govern SRM research and development. I think your point is fair, Rob, that how much of that has involved a broader public discourse, or does it just reflect the academics' concerns and interests? There does seem to be quite a convergence on those high-level principles, though putting those into practice, resolving the technical details, is quite challenging. I just wanted to pick on one that kind of connects with your expertise, Rob. Public engagement. They all sort of recommend there should be sufficient public engagement. But what would constitute sufficient public engagement for, a program of SRM field experiments?
Yeah, I mean, this kind of again depends a bit on your perspective. So, and kind of like, what your kind of view on consent for an experiment is. Whether it's kind of explicit consent, whether it's assumed consent, or whether it's revealed consent, through markets or kind of decisions taken on our behalf by our elected representatives, things like that. So there's that element. And then in terms of stuff that's been done already, we've had a few small public engagements that have been going on in relation to SRM tests and things. I think the best known one is one that took place around SPICE. There was a deliberative workshop, or a series of deliberative workshops that took place around that. So that was kind of like, deliberative mini-publics, small people from the kind of local area who might be affected by a particular test. And I think actually that kind of deliberative experiment showed quite nicely that, scientists doing studies with SRM and also technology developers shouldn't be afraid of public engagement. Because one of the key findings from that piece of work, and stuff that we found in other studies as well, is that people tend to show what's called a reluctant acceptance of research. So, people recognize that these technologies are or can be a bit scary, but at the same time, they also recognize that climate change is also very scary, and we're kind of reaching the point now where we need to consider some of these more radical options. So yeah, in terms of formats, deliberative workshops are a kind of common way of doing these things. There's lots of social science debates then, like within that around methodologically who should be in them, how much influence should they have on decision making, and what scale as well. So I mean, like I say, these earlier ones have focused on local affected publics, but there have arguments been made about, well, if this is a technology that's going to affect everybody on the planet ultimately, should we engage everybody, which is obviously a bit of a logistical challenge. But because this is such a, what we social scientists call an upstream area of science and technology, so we've had some experiments and things taking place, but it's largely upstream of significant research and development. At this stage, it's extremely sensitive to framing effects. So the ways in which we, as scientists, as experts, as communicators, frame geoengineering, have a massive impact on how people react to it, people who have not encountered this idea before. So, there's a kind of responsibility that we all have to be able to try and communicate these things in as responsible a way as possible to try and encourage informed debate.
Another recent piece in Science from Shuchi Talati and colleagues points out a transparency problem in solar geoengineering research, highlighting the large role that private funding has played in this space, either through investment in for-profit enterprises, which is a small part, or more significantly through philanthropic funding for various efforts, including our own SRM 360. Do you all agree that SRM has a transparency problem? And what can we do about it?
I'll go. Yeah, I think it does. I don't think it was always this way. My sense was in the kind of early days, there was a much more of a kind of publicly funded, kind of much more open, and that's when we started to see these kind of the flurry of recommendations for principles about openness and transparency. But yeah, recently we've started to see some of these private ventures and things. So it's kind of the lack of public funding, I suppose, is pushing people towards the kind of less transparent private route. That's my sense anyway.
Yeah, to add to that, I think maybe some of the public backlash to, like, for example, the marine cloud brightening field testing in San Francisco can be a little bit of a scare for some actors. Maybe you don't want to do everything as transparently if you're gonna get into a lot of trouble because of it, and that's obviously not the way to go. We should be as transparent as possible with our research.
I think we do have some good models, though, of publicly funded programs that are being quite transparent and putting things nicely out there. So NOAA's Earth's Radiation Budget Program was originally appropriated by Congress a few years ago. Their website has a really nice list of everything they've funded, every paper that's come out of it. They've been trying to do research highlights on the NOAA blog for anything that gets funded, and they've been in the media a little bit. There was a big New York Times piece that was kind of like the scary, we're trying to find if there's rogue geoengineers, and then you read the paper, right, and we're sniffing the stratosphere to see what's up there, really. So it's exciting, but maybe not as exciting as the media says. But that, to me, is a really good model, and suggests that if we did have more public funding or public programs like that, that would be one way to address some of these concerns really well.
Yeah, I think they talk a bit about the idea of a global registry or some publicly accessible thing that everyone should sign up to. I guess it's quite a bit of work, and I'm not sure if there's any moves to actually institute such a thing. But I mean, I think it would make sense to have sort of publicly available information, because I think many of the philanthropic funders aren't secretive. I think there just isn't a place to do this, and there isn't a specific there's just not a venue to feature it. I mean, maybe there are some things that are on the more secretive side, but I think there is a gap there that could be filled. Well, turning back to the Arctic, a new study by Du-Ying Ji and others shows that implementing SRM to stop global warming, to limit it at 1.5 Celsius in an otherwise quite extreme scenario of global warming, they found that could greatly reduce permafrost carbon losses, though not stop them. Viktor, can you explain what permafrost is for some of our audience who might not know, and what its loss might mean for the Arctic and more broadly?
Right. So permafrost is frozen organic matter or soil in the Arctic region, more specifically in Siberia, Canada, and Alaska. And when the planet warms, this permafrost is thawing and it's releasing greenhouse gases into the atmosphere, like carbon dioxide and the more potent greenhouse gas, methane. And what made a special impact on me was reading the State of the Cryosphere 2023 report. I think they're doing some pretty great science communication on this topic, where they compare the emissions from the permafrost to that of major nations. And so they talk about the nation of permafrost in a sense. There they conclude that if we stabilize at 1.5 degrees Celsius, we would see annual emissions equivalent to that of India throughout this century, which is obviously really concerning, since then we're going to have to do a lot of carbon dioxide removal, which we don't really have a good understanding of how to do on that type of scale centuries into the future, essentially. And if we go to 2 degrees, then the emissions will be equivalent to that of the European Union, and 3 degrees, United States, 4 degrees, China. And so it just gets worse and worse, and every tenth of a degree pretty much matters. But it's not all about the climate when it comes to permafrost. You also have to remember that there's a lot of built infrastructure, like railroads or oil pipelines, just buildings and roads that are beginning to crumble when this previously frozen ground is beginning to thaw. And in many areas, the permafrost can be hundreds of meters deep. So you can get some pretty large changes in the terrain. There's, for example, been a phenomena of lakes disappearing because of permafrost thaw and the water just kind of sinking into the ground into these new channels. So yeah, it's a big topic, and if SRM can keep temperatures at a lower level, then it's pretty obvious that we can expect less permafrost to thaw.
Yeah, they didn't have a direct comparison, as far as I could tell, between the effects of SRM and the effects of there being less global warming from emissions cuts. But it does seem one of the more straightforward examples of temperature playing a really, really crucial role, because it's about frozen soil becoming unfrozen. So we can expect SRM to work well at this, something that cools the whole planet will cool the Arctic and so cool the permafrost. And yeah, as you say, it's an important. It's not a catastrophic contributor to global warming, but it will become a more and more significant contributor, rivaling nations. So yeah, it's quite an important piece. So last up, we have a new study by James Hansen and co-authors who looked at the accelerated warming we've seen since 2010 and argues that melting ice and snow, crucially decreased pollution, as well as thinning of clouds, have all played a role in this surge in temperatures. And in the paper, they do raise the possibility of studying and thinking about potentially deploying SRM. So for those who don't know, James Hansen was a legendary climate scientist. He's one of the ones who, I think he is the one who first sort of declared that it's happening to the US Congress back in 1988 and brought a lot of attention to the subject. So, yeah, just on the content there, Michael, the team concluded that a large portion of the warming seen in 2024, or seen in recent years, is attributable to the new cleanup of shipping fuels that we've seen since 2020. How big a contribution do you think it has made, and have they exaggerated it?
It's generally a bad bet to go against Jim Hansen on a climate change issue, so I'm going to be a really terrible gambler right now and say I'm not convinced by the analysis in this paper. We think that the effect from cleaning up the ship fuel, so there used to be a bunch of sulfur in this field before 2020, then all of a sudden, January 1, 2020, remove about 80% of that sulfur, and that sulfur is what makes those shipping particles really good at forming clouds. So we think that probably produced a warming effect that could be something like half of 0.1 degrees Celsius, 0.05 degrees Celsius over a decade timescale or something. This paper is suggesting something more like 5 times that amount. That is at charitably the upper end of plausible. That's maybe hanging out right at that boundary of the 95% confidence interval from other sources of evidence. I wouldn't go there yet, but again, Jim Hansen has been talking about these importance of aerosol cloud interactions for a very long time. If we had listened to him 20 years ago, we'd have a much better suite of observations that would have let us quantify this with a much greater degree of fidelity. And his overall message, I think, that we've made this Faustian bargain in terms of having this aerosol cooling at the expense of these public health impacts of pollution.
So whether this scientific contribution is the most important part here, but I guess turning to the public impact of this, the impact it might have on the discussion, do people like James Hansen, do their kind of involvement, do they make a big difference?
I think they make a difference for sure. But just to kind of maybe echo what Michael was saying, if we'd listened to him, 20 or 30 years ago, then maybe climate change and its outcome would be slightly different. So maybe he's not had as big an impact on, the public and wider discourse as we would have liked at that time. So yeah, I mean, they do have an impact, but I think again it's something that comes back to the kinds of things people are saying and whether or not that resonates with your worldviews and your values.
So to wrap things up, I want to move over to an audience question, and as it's February, I thought this one would be very timely. One of our listeners, Mark, asks, could SRM make my chocolate cheaper?
Well, we don't really have the technological readiness to impact the chocolate prices yet, but maybe it could have a positive impact in the latter part of this century or the 2040s or 50s.
Something I learned recently is that the environment affects not just how much of the plant you're getting, but also its quality. So maybe just like we're going to get potentially redder sunsets, maybe we'll get sweeter or less sweet chocolate, etc. I think this is an important area of future work.
I think the WCRP missed a key research gap. Well, on that note, thank you all for joining me and for being on the podcast.
Thanks for having us.
Thank you.
Thank you.
Thanks for joining us for our monthly news roundup. Tune in for more episodes of Climate Reflections. And if you like this episode, please rate and review us wherever you got this podcast. The Climate Reflections podcast is a production of SRM 360, a non-profit knowledge hub supporting an informed, evidence-based discussion of sunlight reflection methods. To learn more about SRM or to ask a question, visit srm360.org, where you can also find a transcript of this episode with the links to the articles we discussed.